with the topic of modernization in statistics for 7 Malaysia Statistic Conference, and in conjunction with the World Statistic Day and MyStats Day 2020. So in this session, 3 presenters will share their findings on various aspects under modernization in statistics. And before we go further, let me brief the flow of this session. First, this session will take 75 minutes long, and every presenter will be given 15 minutes to present their paper. The question and answer will take place after all the presenters finish their presentation. Audience are encouraged to use chat meeting for question and answer session and interaction. And while do the presentation, presenter need to turn on the video mode. Therefore, audience can see the presenter. And please be informed that e-certificate will be sent to presenter and audience through email by the secretariat after the conference. And before we further ado, we now already 3 minutes. Okay, and let's move to the presentation part. The first presentation for this session is leveraging open API interchange network data for urban access to health services by Encik Ahmad Najmi bin Ariffin. Encik Ahmad Najmi is one of the finalists for Young Statistician Presenter. Encik Ahmad Najmi is graduated from University of Malaya with a Master in Applied Statistics and joined the Department of Statistics Malaysia in 2019 as a statistician, and currently strives doing his PhD in health economy at National University of Malaysia. And Ahmad Najmi is also one of the core team member for the big data analytics at DOSM that work on establishing to modernize public sector services through managing and implementing big data analysis with the collaboration of other government agencies, empowering emotional intelligence for better future. So, Encik Ahmad Najmi, the floor is yours, and please.
Assalamualaikum warahmatullahi wabarakatuh. Thank you for the moderator for giving me the floor. Good morning, everyone. First of all, I'd like to welcome all the judges for coming in, and also the audience. Today, I will share my slide first. Can everyone see my slide now?
Yes. Yes.
Okay. For this topic, I will describe about the leveraging open API interchange data for urban access to health services. First of all, we need to know what is API, what is the GIS, what is partial analysis in terms of network data, and also the use of contraction therapy in this method. And then we go through with the item package, which is a Pandana that we use overall in this notebook. In this notebook, I will demonstrate the main features of the Pandana library, a Python package for the network analysis that used to construction hierarchies to calculate the super fast travel accessibility metric and the shorter path. For this paper, the objective is to compute the shortest path between the location of the clinic and hospital, and then simplify the measuring proximity to the closest dental clinic and to each network node, and then evaluate the urban access to health services, and then mapping the access challenge present that can be identified. For API, we hear API everywhere, but what is exactly API? Why do we matter so much? Think about successful companies, for example, Google, Yahoo, and many more. They delight and connect their customer through the powerful apps and convenience. Super fast digital experience, application, programming interface, they make this magic possible. API are the software interface that let different computer systems and applications to talk one to another and share the information. API also gives the developer frictionless and secure access to the company data, so they can build all these amazing apps. API are like digital building blocks, which combine into amazing experience that make our life better and more convenient. Are you get the picture right now? You, your partner, employer, and the customer expect you to be easy to interact and connect with. We're gonna be digital, so it's gonna be the API. And then what is GIS? GIS is stand for the Geographic Information System, using the computer hardware, software, and ton of raw data. We can explore the fundamental principle of the geographic that location is important in people's life. Using that, we can view, understand question, visualize, and interpret data in visual way that will connect the relationship and pattern which allow us to make better decisions. For example, a city planner can choose the best location for the new park or hospital, ensuring that they are building in the place where they are needed the most. GIS is essential to understanding what is happening, what will happening in the geographic space. Geographic understanding bring wisdom, and with wisdom we can make better decisions to create a better future. And then, what is different between GIS and network node approach? GIS is a attribute of, for example, input of 2 points, which is, for example, from this slide, point A and point B. For GIS, we can calculate the distance across the obstacle. For example, obstacle of the hill, of the lake, or of the highway. But for the node network, they are built in the node for each injunction from the road in the real map. Although there are advantages of the GIS approach, we think that network theories are more accurate to speak how people interact with the environment. And then we describe about the network path. For the network path, we now have a fancy algorithm to figure out minimum the shortest distance and the sort of thing. The shortest path between 2 points, for example, here from this diagram, from point A to point G, the 2 point in the network is the path where the sum of the weight and each is minimized. It's basically the shorter working distance. If we are going to imagine it, we are working or driving between 2 points. From here, the network shorter path, we try to find the shorter path between 2 vertical or line. Select all the likely shorter path, the point, the tree from here, and calculate the length. Compare the different path length by the shorter. From the example here, we can see that we have two paths, which is ABCG and also AEBG. The final calculation shows that the shorter path for the AG is from the first path, which is ABCG, which is 7. Yes, describe the concept of network shorter path. Next is we are going to drill down into the spatial analysis and data science. Many of you have seen the result of anything like this one, and see up here that happens behind the scenes before you can start to visualize, explore, and make the decision. The geospatial infrastructure for analysis is something that we are going to touch. Very often, analysis start with the data because we all use true information can be extracted from. OSM or OpenStreetMap contain open data, database that work with this type of data, can bring them together. For this study, we hosted the notebook integration with the OSM API, with the GIS features to bring all the workflow into one place. The goal is to make a highly productive. We all run this within the same environment because we have the full control within it. Although at your fingertips and possible within the Jupyter notebook, and of course the experience in driving the Python very scripted, which is widely available and known in community. How will this work? You will have a Python notebook that you experience within the browser that call into the notebook IDE, it's a bundle of open source library, and run the system. For this study, we are using Pandana package. The next one, we go to the methodology part. For the methodology part, the network from the OpenStreetMap using the Pandana function, by default, that generates the network contain only the walkable route from the map, especially the type of drive to get the drivable road. This network has one integer set named distance, which is between the node in meter. The transportation network in Siti typically in data with the distance based from the OpenStreetMap or travel time from the GTFS data, which is from Google. The Pandana has some support to take the network from the OpenStreetMap API and store the network data to this HDF S5 so that it can be restored later. For the OpenStreetMap API, Pandana makes the network from the bounding latitude and longitude via a request to the Overpass API. System will be in meter and requested need to install the OSM library. This is the boundary. For this overall session, we describe the loading data, path, proximity, stability, and visualization. This is an example of data has been loaded from center of Kuala Lumpur, Malaysia. We call the code and straightforward. And instantly we get the whole data. Before that, we need to decide the designated area that we cover in this example. For that, we get the boundary box from the coordinate and bounding box from the bounding box pre-tool website. For the analysis part, we expected to have a simple number calculation. Simple number calculation as well, which is the number of dental clinic, number of hospital, and also number of public transportation station and platform. And then we calculate the shorter path, proximity, and accessibility of this location. And then we visualize in mapping format, and from that we limit all the variable parameter are set at the maximum distance of 1,000 meters up to 3 nearest point of interest. This is an example that we scratch up from the OSM database API. From the result shorter path group between the facilities, the system identify the nearest node to each dental clinic, hospital, public transportation. From that location of health services listed from the OpenStreetMap OSM using the same OSM extension, and then calculate the shortest path. Here, we know that we try to get the ability of dentist, hospital, clinic, station, all these types is standard for the world. Pandana can generate several million shorter paths in less than 1 minute. As you can see from the first slide as shown, the loading data is only take about 30 seconds to get all the data in our database. For the shorter path, proximity shorter path between the location of the data is about 1,800 meters and 150 meters. We can get directly from the code. Proximity is we try to find the closest dental clinic or hospital to each node. Formally, we need to add the dental network, and then from that, the max distribution and max item, max distance and max item, which are the maximum distance item. Execute using the proximity distance so that Pandana can optimize the content. This is the code that has been used. Just like in we got the 3 processes that can be set that to be maximum. and we get around 900 to 1000 meter for each node. This is actually one of the main findings for the accessibility. We try to get how many data clinic or hospital are within 1000 meter of each node, so we can set whatever distance that we need in that unit or within that unit. The computation mean, mount, percentile, and other metrics as well imply line potential decay to more distant value. For this part, we are using the count value. And as a result, the Panda kind of aggregation shows that 6 unit data clinic are located within 500 meters of each node and 10 unit within 100 meters. Aggregation information for each node in the network is really the main purpose of this library. This allows us to track the data specifically by calling the stack and perform sub-aggregation on it within the specific distance. For instance, we sum up the population within 1000 meters. For this case, we sum up the population of 10 to 1000 meters. For visualization part, this is the cluster or density within the dental clinic that has been plugged in. It shows that mapping dental clinic as the hotspot location of dental clinic in Kuala Lumpur within 500 meters. Yeah. For make more clearly, we overlay the map and the point with the in one page, and we can plot the spatial data of dental clinic in Kuala Lumpur, and we find out the real time from the real time mining. We found that 74 dental clinics around the boundary area, 2 hospitals, 267 clinics, 140 public transportation, and 23 public transport platforms are located within the zero-netted area. So, for the discussion, it proves that Kuala Lumpur.
Najmi, you only have 1 minute left.
Very comfortably, then. So, there is need to proceed or to continue with this study to make sure that the applicant approves the plan services structure. We can select data from the NSO, update and secure, continuous demonstration geographic distribution, special approach to provide data set distribution support tool, and we compare the social element of public healthcare facility. All from me. Thank you.
Najmi?
Yeah, it's finished.
Okay, so thank you.
Okay.
Unfortunately, we cannot hear quite clear just now. But what Encik Najmi tried to say is, instead of using GIS, so he tried to use API, Application Programming Interface, to do sort of network data for urban access to health services. And this is quite technical for laymen, but I think this is a good move towards improvising the needs of granular statistics, as well as to enhance the data science field. So thank you again. And we move to the next presenter. The next presenter is Puan Azuraini Muhammad Arif. Puan Azuraini Muhammad Arif is actually a lecturer of mathematics and statistics in University Pertahanan Nasional Malaysia. She is from Jabatan Matematik Pusat Asasi Pertahanan, University Pertahanan Nasional Malaysia. So Puan Azuraini is not with us, but she sent a video with the topic of an outlier detection method for balanced replicated linear functional relationship model. Please.
Assalamualaikum warahmatullahi and very good day. My name is Azuraini binti Muhammad Arif and my supervisors are Professor Dr. Yon Zulina Zubairi from University of Malaya, and Professor Abdul Ghafur bin Hussein from University Pertahanan Nasional Malaysia. The title of my presentation for today is an outlier detection method for balanced replicated linear functional relationship model. These are my presentation outline for today. We will start with an abstract, proceed on introduction, a little bit on literature review. Next, we will discuss a little bit on maximum likelihood estimation method, covariance matrix of parameter, detecting outliers using COVRATIO, and also determining the cutoff point. Then the proposed method are applied on IE in SLAG data. Last but not least, the conclusion and also references that have been used in this study. In this study, we propose a method to detect an outlier in replicated linear functional relationship model. Linear functional relationship model is one type of error invariable model. Based on the idea of COVRATIO statistic, we modify the procedure to ensure it works well with the replicated linear functional relationship model. We use 10% upper percentile to obtain the cutoff point, and we illustrate on the real data set. If our purpose in investigating the relationship between the variables, or usually we use the linear regression model. In linear regression model, we assume that the variable involved are measured without error. However, in error invariant model, is a regression model that takes on the measurement error in the dependent variable. If these errors are ignored, the estimator obtained by classical regression are biased and inconsistent. For example, Barnett has been used the error invariant model to investigate the calibration problem, where his aim was to investigate the relationship between new instrument with standard instrument. The observation is considered as an outlier if it does not follow any pattern with the remainder of the other observation in the dataset. The issue of outlier has received critical attention that need to be investigated. For example, when the observation in an experiment is incorrectly recorded or dataset is mistakenly entered in the computer. It is important to detect such outlier as their presence in the dataset will give a remarkable impact in the statistical analysis. Now I will explain a little bit on balanced replicated linear functional relationship model. It is one type under error invariable model. Suppose we have a linear relationship between xi and yr are given by this equation yi equal to alpha plus beta xi. Alpha is the intercept parameter and beta is the slope parameter. In this case, xij and yij are subject to random error delta ij with parameter mean 0 and error variance sigma square, and epsilon ij with parameter mean 0 and error variance sigma square. On literature review, Edgar RJ is the first person who described the appropriate method for the error invariable model problem. Since then, there are several authors who are interested in estimating the parameter with replication, such as Barnett in linear functional relationship model, Chan and Mark Dolby in linear structural relationship model, Hussein in circular linear functional relationship model. Bersley was the first person who introduced COVRATIO statistic in identifying outliers in a linear regression model. Since then, there are several authors who has been used COVRATIO statistic in their model, such as Abu Zaid, Ibrahim in circular regression model, Ghafur in linear functional model, Ramli in circular functional model. The estimation of the parameters may be obtained by the maximum likelihood estimation method, which involve an iterative technique. The log likelihood function and the parameters can be shown on the slide. Next, we find the covariance matrix of the parameters. the asymptotic variances of the estimator can be found by inverting the estimated feature information matrix for equal and balanced replicated linear functional relation model. Thus, we can get the covariance matrix of the parameter in the model and also the determinant of the covariance matrix for this model as shown on the slide. Next, we detect the outlier using COVRATIO statistic. We use the proposed statistic given by the COVRATIO minus 1 equal to determinant of COVRATIO divided by determinant of COVRATIO minus I, where the determinant of COVRATIO is the determinant of covariance matrix for full data set, and the determinant of covariance minus I is the determinant of covariance matrix by the proposed method. The covariance minus I is obtained by deleting the ith observation of every group, and this observation is repeated with mean of every group to make balanced replication of all sample groups. Any COVRATIO minus 1 with observation exceed the cut-off point will be considered as an outlier. Next, we need to determine the cut-off point. We carry out simulation studies on our software. There are several steps that need to follow. Step number 1, we generate xi equal to 10 times I over p, where p is the number of groups in the size of n equal to 20 until 300. We set either intercept alpha equal to 1, beta equal to 1, the area variance sigma square equal to 1, and we use different area variance tau square from 0.2 until 1. Step number 2, we generate the two random errors by the distribution given. Step number 3, we calculate the observed values and we feed the generated data by using the parameter replicated linear functional relationship model. Step number 4, we find the variant covariance matrix and calculate the determinant curve for all data. Step number 5, we delete the I observation of every group and replicate with mean for observation in every group. We repeat step 4 until step 6 to obtain the determinant COVRATIO minus I. Step number 6, we calculate the COVRATIO and find the value of COVRATIO minus 1 for all I. Step number 7, we specify the maximum value of COVRATIO minus 1. And step number 8, the process is repeated for 1000 simulation and the 10% upper percentile of the maximum COVRATIO minus 1 are obtained. This table shows the value of 10% upper percentile of COVRATIO minus 1. From the table, the mean of the value for each n are calculated and the power series formula is plotted. We consider 90% confidence level and thus the cut-off point is to be at 10% significant level. Or thus the cut-off point is y equal to 5.2418 times n power of negative 0.407. This cut-off point will be used to determine the outlier. So we apply the proposed method to iron in SLAG data with n equal to 50. The data is taken from Hand et al. The purpose of this data is to investigate the extent to which the result of a chemical test of iron content can be predicted from a magnetic test of iron content and the nature of the relationship between these quantities. This data represents observation taken by each of two different techniques, namely the magnetic test and chemical test, which are subject to measurement error. Thus, replicated linear functional relation model is more applicable than regression model. From the figure scatter plot, since there is no outlier in the original data, we modify the data by following Kim and Himon and Hadi. We insert outlier at the 32 observation as in scatterplot modified data, and we apply the proposed method. From the figure 3, we can see the 32nd observation has higher value of COVRATIO -1. From the cutoff point determined from simulation study, we substitute n equal to 50 and we get the cutoff point y equal to 1.0666. The value of 32 exceed the cutoff point. So the value of 32 is 1.7x71. Thus, the 32nd observation is currently detected as an outlier of the data set through the proposed method. In conclusion, 90% confidence level is considered and thus the cut-off point developed is to be at 10% significant level. The COVRATIO statistic is used because it is simple procedure, widely used and easy to implement to conform with replicated linear functional relationship model. Last but not least, the proposed method can be used to identify an outlier present in the data set. These are my references. That's all for today. Thank you.
Thank you, Miss Azuraini. Sorry. I think we have finished all the presentation, and we can go to the question and answer if any. All the audience can use the meeting chat to ask the question, or can also raise your hand to ask the question. So please, any question? You can also raise hand features on the screen if you want to ask any question to all the presenter or to any of the presenter. Balkis want to ask regarding Miss Azuraini presentation. So is it Miss Azuraini is here? Because just now we just listened to the video. Puan Azuraini or any, I guess Puan Azuraini is not do alone. She did this paper with someone else. So if Puan Azuraini is not here, is it Dr. Yong Zulina is here? Or Mr. Abdul Ghafur, is it here? Yeah, we still waiting for Puan Azuraini. There is an question to you about the method on detect outlier. So is it only for modeling? That is the question. And how about like large survey data? Okay, Puan Azuraini answered through meeting chat. It could be applied to survey data, but we do need to take care of missing value which also present in the survey data. Okay, is it okay for you, Balkis? The answer? Okay, thank you. Any question? Any else question?
Excuse me, Puan.
Yes.
Salam sejahtera, Puan. I have a question for Cik Najmi. For his presentation about the accessibility. So he mentioned about the accessibility of his outcome. So does that take care into the real world? I mean, the real situation out there? Because from his slide, he's just considering on the computational results. But in reality, how does he relate the result to the actual situation out there? I mean, can he comment on that, please?
Okay, please, Najmi. Najmi.
Hello, yes, Prof. I can hear your question. From the reading, we find that in real life, based on this data, we don't have the the solid or accurate data yet for this sample. For that is a good or benefit. If this really benefit the government,
Yes.
we can get the crowdsourcing data in one place. For example, from I think the yesterday conference from forum, they have established the healthsite.io. They try to get the crowd data from anyone, anywhere with the solid attribution as well.
So from your experience now, what are the main difficulty or what are the challenges that you have faced so far?
The main challenges is
I heard you say Python is very fast, right? In terms of extracting the data and all that. Yes.
The limitation is maybe I cannot verify or consolidate each data point is the correct one. So I need to get a few sources from not only in one source. For example, for in Department of Statistics itself, we doing the fieldwork. That's mean we go to the premise and check is it the premise in there. So that's why in NSO or the Department of Statistics Malaysia, we can verify the location of the premise. That's why. So I answer your question.
Okay, thank you.
Okay,
good luck.
Thank you.
Okay, thank you, Encik Najmi. Puan Azuraini also have answer on just now on the method, and she said that the best method to detect outlier could be depend on the model itself, and so it's hard to say what is the best method. And Puan Azuraini also putting here that she using COVRATIO because it's easy to implement in this model, and perhaps we could use another outlier detection method also. And another question to Encik Najmi, what is the limitation of using API? Encik Najmi, can you please answer?
Okay, thank you. I think this same question, but I try to answer it different way. In daily life, we use the Waze, we use the Google, any other than that. They are the paid software actually. Paid software. For example, for Google API, they limit that 2,500 for daily crawling data. That's why the limitation is in terms of paid. So we need to get the proper sample or proper calculation to get the actual data, the exact data that relate to our objective. That's why we need to have the initiative to get the data that already free and can be used to anyone that really need it, because this data is benefit everyone. That's all for me.
Okay. Yeah. Anybody? Or if there is no other questions, so before we end, we will have a virtual group photo session. And in this respect, we wish to request for all the virtual participants to ensure that your camera is in active mode and your face is facing the camera. Cheers and do the thumbs up. And we also would like to thank you for joining us for today. We hope that you are benefited from the session today and have a nice day.